5. And the first two problems are all about determining if graphs are differentiable at a point. So basically at where x equals 0. We're looking at where x equals 0, right? So what does a rough sketch look like graphically? It's got a first point right here, and obviously this is a cusp. So graphically, this is f of 0, right? Graphically, f prime of 0 does not exist because of a cusp on f of x, which means because the derivative is not the same from the left and the right. It's not the same. So the limit is not the same from the left and the right. Therefore, when we get to 0, that derivative is not going to be the same. Okay? Analytically, we just find the derivative here. F prime of x equals 2/3, and x to the negative 1/3. Okay, that's what it looks like. So f prime of 0 it's going to be 2/3 cube root of 0. That's going to be 2/3 times 0, which leads me to 2/0, which does not exist. So I proved this analytically as well as graphically that this derivative does not exist. Okay? So for f prime of 2, I'm going to create a rough sketch of this graph. And you can always use graphing calculators to kind of see what the overall graph looks like. But it's just to be helpful. But here, this graph starts at 2, 0, and then it extends all the way to the right. All right. So is there a derivative at 2? F prime of 2 does not exist. It's undefined. Simply because the left hand and right hand limit it's lacking the ability to be continuous. Okay, so let's look at that analytically. We have f of x equals 4 minus 2x to the 1/2. So I have to differentiate the outside and then the inside. So 1/2, and then that group times a derivative of everything inside, -2, and this is to the -1/2 right here, this group. So if I want to find f prime of 2, what we'll find is that that does not exist. So I have -2/2 square root of 4 minus 2 times 2. That equals -2/2 square root of 0, and that just equals undefined. So prove that analytically and graphically. So you will do these on your own. Definitely make sure you take a picture of what you do on your own, and I will do the top part. All right. So when you're looking at this, the way I determine what I want is right here. 2 minus minus 3. Okay, also right here and right here. Okay, so that helps me kind of figure out what it is I am looking for. So these are definitely worthy of practice. So just using find each of the indicated limits below. You do not need to use the alternate definition of derivative. Find the derivative. You need to identify the function and then get the derivative. So right here, my function, my original function is x. So what I'm going to produce is f prime of x. It doesn't tell me to evaluate at a point, just tells me to find f prime of x, and I'm done. Right here, f of x equals, if you could look just right here, equals 2x minus 3, right? So I have f prime of x equals 2, right? Down here, they want me to evaluate this limit at a point. I don't have to use the definition of derivatives here. So f of x equals sine x. Okay, that means f prime of x equals cosine x. They want me to evaluate at a point. And at this point, this derivative equals 0. So you should be able to do the last one on your own right there. All right, flip the page. The equation of the normal line to the graph of this is y equals e to the 2x when dy over dx equals 2. So when y equals 2, what is the equation of that normal line? So first of all, y prime. So this is the slope of the tangent. Therefore, I don't need to work to get the slope of the normal line. I know it's the opposite reciprocal. That slope is the opposite reciprocal. All right. The other thing I need to figure out is what my x and y values are. So I need my point of tangency. So x1 and y1. I need these. And the way you get it is you look at the original function here. All right? You get the derivative of that original function. Y prime equals 2e to the 2x. And then you basically search for the x value using that slope of dy dx. And remember, this y prime is dy dx. All right, so 2 equals 2e to the 2x. I want to divide both sides by 2, and I get 1 equals e to the 2x. Or you could take the natural log of both sides, which is preferable, of this whole thing. And that's going to give me the natural log of 2 equals the natural log of 2. And these are logarithm rules. Remember, when you have two things multiplied, product inside, you separate them, you can add them. And e to the 2x. And what happens is we have natural log of 2 minus the natural log of 2, if I move it over to the left, equals, now simplifying this, I just get 2x. I have 0 equals 2x, or x equals 0. So now I have my x value. So that means I can find the y value for that point of tangency. Find the y value. Y equals e to the 2 times 0, or just 1. So now I have my point of tangency. I have my normal line equation. So y minus 1 equals negative 1/2 times x minus 0. This equals y. If I want to put it in slope-intercept form, y equals negative 1/2 times x plus 1. And you will see this type of stuff possibly on your test, and you'll see it in the homework or in the notes tonight. Given that f of x equals that, what is the approximate value of 1.1? So if you do it with a calculator, you're going to get this, but we want to approximate this value. So the way we do that, we get the derivative. So I have 2x e to the x plus x squared e to the x. I check it at 1. So I have at 1 equals 2 e to the 1 plus e to the 1, and this is going to equal 3e. All right. Now that I have this y value, your question is, how do I do approximations for this? Well, what you do is this. Okay, so I'm not really sure why this comes up, but it's overly complicated. But I found now I know that f prime of I know f prime of 1 equals 3e. So they want me to approximate the value of this, and you can do this. It's kind of antiquated given that approximations are off. So calculator would produce a more accurate answer, but they're talking about, do you know how to calculate do you know how to approximate the value of 1.1 using the equation of a tangent line? So we can get this. We're looking for a y value. We're going to use a tangent. We're going to use this information to approximate this. So you're going to see me do this. So we're looking for y minus y1, okay, equals n times x minus x of 1. Y we don't have, minus, anyways, I'm listening. Shame, shame, shame. Anyways, so find f of 1. So this is the value for 1, this is the value for a y value of 1, this is x value for 1.1, and this is the y value for 1.1. And f of 1 is 1 e to the 1. Okay, so y equals 3 e to the 1.1 minus 3e plus e. And you should get 3 points. Five, 3, 4. Okay, and that should be all that she wrote. Oh, my bad. Should get let's see here. That's 3.3e minus 3e plus e equals, let's see, 0.3, 1.3e, which equals approximately 3.534. And we want to approximate. Here, find the derivative, and you'll get your answer there. All right. And I will leave it there. You can do the rest on your own. Have a good day.